Alright, we're going to take a look at rational exponents. The word rational means fraction. Okay, so we're essentially just looking at exponents that are fractions. They come kind of from radicals and square roots, and cube roots and fourth roots and so on. Okay, so we're going to take a look at question number 1 here. Essentially, when we want to change from radical form into rational exponent form or fraction form, this guy is going to be our numerator, and whatever you see out here will be your denominator. Okay, so this is going to end up being x to the exponent 4 over 3. Okay, now if we don't see a number like number 2, if we don't see a value out here, we assume that it's a 2, because what we see there is a square root. Okay, and that's the opposite of squaring something. So our 3 will go on the top, and our 2 will go on the bottom. Okay, we could also have multiple variables in here. Remember, this squared only applies to what is directly in front of it. So this x actually has an exponent 1. Okay, so we're going to take each of these individually, and we'll do top, bottom, and top, bottom. And if you ever see a rational exponent that can be reduced, you're going to make sure that you reduce it. Okay, so this will be y to the exponent 1/2, because 2 over 4 reduces to 1 over 2. Okay, we'll try something a little bit more challenging here. Okay, so we know that outside this bracket, because it's a square root, or not bracket, but outside the root, is an imaginary 2 here. Okay, and we're going to take each of these individually, so I'm going to do x to the exponent -4 over 2. And then this one is a little bit more challenging. It's going to be 6 over 5 over 2. Okay, so let's just take a look at that little part off to the side here, because that can be a little bit confusing. So we essentially have 6 over 5 over 2. Okay, and if I have a fraction inside a fraction, it's not a big deal. All I'm going to do is I'm going to think about this as 2 over 1, and I will flip and multiply. Okay, so we end up multiplying by 1/2. And the best thing that you can do before you multiply the numerators and the denominators is to reduce any individual fraction or to cross cancel. So cancel any numerator with any denominator. Remember, you can only do that when you're multiplying two fractions. Okay, so that will become 3 and that will become 1. And now we can just multiply straight across here. We'll do 3 times 1, which gives us 3, and 5 times 1, which gives us 5. Okay, so that's what that value is going to become for our exponent b there. So -4 over 2 reduces to -2, and this b exponent, which is what we just found off to the side, is 3 over 5. Okay, there's one last thing that we need to do, and that is that we cannot have any exponents expressed as negatives. Okay, it's just kind of like proper mathematical form. So we are going to take our b, 3 over 5, that's going to stay in the numerator, but this entire thing with the negative exponent is going to move down into the denominator. So take the value that has the negative exponent, so the base and the negative exponent, and move that entire thing into the denominator. And when we do that, we can make the exponent positive. Okay, now this is expressed in proper mathematical form, so we are in fully simplified form here. Alright, this is going to be our last one for this video. It's a little bit more challenging yet. The first thing that I'm going to do, I'm just going to start with the numerator, and I'm going to change these values, the m squared and the p, with this cube root into rational exponents. So remember, this p has an imaginary exponent 1 on it. So it's going to become m 2 over 3 and p 1 over 3. Okay, over with this q here, I'm going to apply power rule. So an exponent to an exponent is going to end up being multiplied. Okay, so we're going to have q to the exponent -6. Okay, moving down to our denominator, I'm going to leave the q and the p squared by themselves, and then I'm going to also just change these two values here into rational exponents. So remember that there's a 2 outside of that square root, and this m has an imaginary exponent 1. Okay, so it becomes p 3 over 2 and m 1 over 2. Okay, great. So we can do a couple different things now. What I think would be the best thing for us to do is start by applying the negative exponent rule. Okay, so I'm going to take this q to the -6 and I'm going to bring it down into the denominator, make it positive. And I'm just going to gather these two p's here, I think, just to start. Okay, so I'll leave the m 2 over 3. I'm going to leave the p 1/3. And then we're going to have q. And in order to gather these two p's, I need to have a common denominator. So this p to the exponent 2, I need this to have a denominator of 2 because this guy has a denominator of 2. Okay, so this will become 4 over 2. Okay, we kind of think of this as if it's like 2 over 1. So I multiply the bottom by 2 and I multiply the top by 2, and now both of our p's have a denominator of 2. Okay, we know when we're multiplying two things at the same base, we have to keep the base and add the exponents. Okay, we'll do that on the next line. So we'll have m to a half and q to the exponent 6, and those are all being multiplied there. Okay, so we'll go up to the second part of this here. I'm going to leave the m and the p for this step. Oh, that was bad. Okay, and we're going to gather the p's and the q's. So the q has an exponent 1. Because they're being multiplied on the bottom, they're going to end up being added. So 1 plus 6 is 7. And then with my p's here, we're going to have 4 over 2 plus 3 over 2. That gives us 7 over 2. And I still have an m to the exponent 1/2. Okay, so now what we need to do is gather the things on the top with the things on the bottom. So I need to gather these two p's, the one on the top and the one on the bottom, and these two m's as well. What they're going to do is they're going to end up being subtracted from one another. So if I'm subtracting two fractions, I need a common denominator. So common between 3 and 2 is obviously 6. So I'm going to multiply the 3 by 2 and the 2 by 2, we'll get 4 over 3. And the p's, coincidentally, will also have a denominator of 6 because they also have denominators of 3 and 2. So this is going to become 2 over 6. The q can stay as it is because it's already simplified. This p is going to have to be multiplied by 3, so it'll be 21 over 6. And the m will also have to be multiplied by 3, so it becomes 3 over 6. Okay? So for the m, I'm going to have 4 over 6 minus 3 over 6, and then the p will be 2 over 6 minus 21 over 6. And the q is going to stay on the bottom because that's where it is, so it doesn't move out of there. And we're just going to simplify these out. Actually, I'm going to do that on the next page. Okay, so 4 over 6 minus 3 over 6 ended up being 1 over 6. And 2 over 6 minus 21 over 6 ended up being negative 19 over 6. And the last thing that I need to do here is just take any negative exponents and switch the side of the fraction. Okay, the whole thing, including the base and the exponent. And I'm going to move that p into the denominator. And then I can make the fraction positive. Okay, so this is what we end up with for this question. Okay, also make sure to double check your fractions and make sure they're all reduced. I can't reduce 1 and 6 or 19 over 6, so I know that that's my final answer. Okay, I hope it helped.